Okay, so the idea is to talk about the translation Lookaside buffer and the MMU. We should have added here MMU, Memory Management Unit, and how they approach the memory in order to bring the memory to the CPU while not taking all the program itself into the cache, into the a very high speed memory, because the main program may be very large and it sits in the physical memory. Now the page table is also in the main memory, and this tells me for each virtual page where is the physical frame for it in the physical memory. Now this also to get to the page table, that for example if CPU runs a process, it gets to itself a virtual memory, and for each place in the virtual memory there is a place in the physical frame. And if I want to get something from the physical frame, I need to go throughout virtual page, then physical frame, and to get the data from the physical memory. So what happens is that translation Lookaside buffer contains the pages that I take very frequently from the CPU, from the memory. I mean, if my program call for certain page, certain physical frame, the translation Lookaside buffer save this. He knows that this program needs this data. The other data of the program is in the physical memory, but the things that the program frequently call to are saved in a much higher speed area, which is the translation Lookaside buffer that sits in the cache, which is much faster memory and closer to the CPU. Now, let's look how it works. So, if I need virtual address and I see it in the translation Lookaside buffer, great, I can get to this area in the physical memory and get the data itself and bring it back to the CPU. That's what he needs. Data is retrieved and sent back to the CPU. Great, but if the virtual page is not in the translation Lookaside buffer, I'll need to bring it from the page table to the translation Lookaside buffer, it will be much slower. So this was a case of a hit, namely there is the data or the translation from virtual page to physical frame in the translation Lookaside buffer in the MMU. But what if there is no? So let's see a miss. So if I need a virtual address that is not in the TLB, I need to go to the page table and find it right over here, get to the physical memory, and bring it back to the translation Lookaside buffer or the CPU and save it in translation Lookaside buffer. I mean, we needed to go to the page table. There, from here, we knew where to go to the physical frame. Here, the data is here. I can get it to the CPU, but also I will save this data in, I will save this translation from virtual page to physical page in the TLB. So next time, when I'll call this virtual page, I'll be able to immediately go to the TLB and immediately get the physical frame and go straight to this data, because now the TLB saved this translation because you know that this program uses this part of the memory. Okay, so all the idea of the TLB in the MMU is to let the CPU get much faster the data he needs from the memory, do the translation from the virtual address in the CPU to the physical frame in the data in the physical memory. So again, if there is a hit, I have a virtual address, I go to the TLB, get it, go to the physical frame, get the data, which is here, this is the data, and get it back to the CPU. This is a fast process, which was because there is a hit. There is in the TLB the translation we needed. But if there is a miss, again, I have a virtual address from the CPU. This is not in the TLB, there is a miss. Going to the page table, bring it to the TLB, and from the and I know now what is the physical frame. I can take the data from here and bring it back to the CPU. This was a miss. This is much slower, but next time when I will want this virtual address, when I will get this virtual address from the CPU, I'll know very fast what is the physical frame because the TLB get will have this translation right away. So this is the idea of the TLB to make the requests for translation of virtual address to physical frame much faster for the CPU because it's much closer to the CPU. It's in the cache in the MMU, and that's the idea of it, to make the progress much faster and not each time that the CPU will go to the physical memory. It will be very slow, or the page table in the memory, it will be very slow for the CPU to work that way. The TLB contains small but frequently used virtual pages addresses such that the translation would be much faster. Now, if the translation Lookaside buffer get too much big, I mean, is full, so next time the new request will just delete one of the lines in the translation Lookaside buffer. Which line? The line that is least frequently used, let's call it, maybe. Any algorithm you want. Okay, so this was the idea of translation Lookaside buffer and the memory management unit, MMU, in the MMU. Thank you very much. If there are any mistakes or corrections, please tell me. And for now, I think that that's it. We'll just see one more time the heat process when there is the translation in the TLB, and that's it.